All right, welcome back to A2 Audio. Today on the channel, we're going to start working on a Pioneer SX-737. And so just a little back history. I've had this 737 in my shop now for a while. I've probably got about 7 or 8 737s in the shop. And had a subscriber reach out to me. Hello, Gordy. Thanks for calling. And say, hey, man, I'm looking for a 737. Can you help me out? And I said, well, I've got some that I can restore for you. Let me know what your thoughts are. And so he got back with me and he wanted to go ahead and have me restore a 737 for him. And so right now it's not much to look at. It's dirty and needs some service. So we're going to go along on this adventure together and we're going to get this thing looking good and sounding good for Gordy. All right, so kind of what's on the agenda for this is obviously we're going to get it cleaned up. We're going to take the faceplate off and clean that. We're going to get the case cleaned up. I haven't decided whether I'm going to put a new vinyl wrap on this or not, or if I'm just going to clean the case. I'm going to clean the case first, and then if it doesn't look up to par, I'm going to go ahead and put a new vinyl on it. Once we get the faceplate off and all the knobs, we're going to go ahead and let those soak in my simple green. I'll link to my video here where I talk about how to clean a faceplate. We'll do that. We'll let that get nice and clean. And then in the meantime, we're going to go ahead and start swapping out all the lighting in this and make sure we put LEDs. If you've been watching the channel, you know I'm a big fan of LEDs. It just decreases the heat of the unit and saves the plastic holders for the light bulbs and especially that dial indicator. So once we get that in there, you know, I'd say there's a 50-50 chance whether that dial indicator breaks because of the heat of the incandescent bulb and just that plastic. But if it does, I have a secret surprise if we break that and we need a replacement. So I've been working on something. From there, my typical restores, we're going to go ahead and clean all the potentiometers and switches. We're going to rebuild the power supply board with new transistors and electrolytic capacitors. We're also going to redo the amp board as well with new transistors and electrolytic capacitors. Sorry about that. That's the timer for another faceplate that I'm cleaning. And I'm not going to edit this out. You guys will just have to live with that timer going off. So, but from there, we'll move on to the protection board and get that squared away with new transistors and electrolytic capacitors as well. And then after that, we're going to go ahead and test everything, see how we're doing. If everything's checking out good, we probably won't do anything else to the unit. And so from there, it'll be good to go. So I'm not going to go into as great detail of restoring this, but I figured I'd bring you guys along for the ride so you can kind of see, and I'll highlight anything that I think is important or specific to the 737 that we should talk about. So without further ado, come on in closer and let's get started. All right, so let's go ahead and get this case off, and you do that by taking off the 2 screws on either side of the case. Okay, now in order to get this faceplate off, there's going to be 2 screws up here, and we'll have to remove these knobs and there'll be some nuts behind that. But before we do that, let's go ahead and remove the bottom cover.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Okay, from here, all we have to do, guys, is pull these knobs off. A trick you can do if you're having a hard time getting one of these off that I like to do is I'll get a piece of string and I'll put behind it and then I'll pull on it, and that'll help me get it off. That'll give me the leverage. So if you're having a hard time, you can always try that. Now once those are all off, it exposes, we have 2 nuts on here. We have one on the base pot and one on the volume pot. And so we're just going to take a socket. Usually these are hand tight. This is a 12mm socket. And it's on there pretty good, so I'll need my wrench. And then I can just loosen them by hand. Got to take off these 2 screws on the top here. Be careful when you do this because after you get that last screw out, the faceplate will be ready to come off. And you don't want it falling to the ground and breaking that glass. So now we have this off, and now we can go ahead and bring this to our simple green bucket. Again, I've linked that in the video, faceplate cleaning, so you can see exactly what I do to go ahead and clean this faceplate. So let me go ahead and change the camera view and we'll get started on our first side. All right, so here we have the case off and the faceplate off. The knobs and the faceplate are soaking in some simple green right now, so let's go ahead and get started on this restoration. So this unit is already working, so there's nothing diagnostically that I have to do to get it to work, so that's a plus. So when we take a look here, we've got a few components. We've got our tuner board, we've got our power supply board, and we got our amp board here, and this big heat sink, and then obviously our relay and our filter caps. So I think what we're going to start on first is going to be this power supply board. And so this board has 11 electrolytic capacitors and 4 transistors. And so those transistors are here, here, and there's 2 little ones here. Now I always recommend referring to the service manual and then doing your due diligence to make sure that you're doing good substitutions for your transistors. For your electrolytic capacitors, it's as simple as taking it out and putting the same one that you see back in there. Most of the time when I do power supplies, I will try to size up the electrolytic capacitor. And what I mean by that is, so like this one here is 1,000 microfarads and 50 volts. So if I can, I'm going to try to put a 63 volt electrolytic capacitor here. I keep the capacitance the same, so the 1,000 microfarads won't change, but the voltage you can go up on. And so I've mentioned this in other videos, but a lot of times manufacturers, when they built these boards, they put in a part just good enough to get by. And so because of that, sometimes it led to failures. And so I don't want there to be, I don't want, you know, this board running at 45 volts and we have a 50 volt capacitor here on that part of the circuit. So I'd rather have plenty of headway and then put good capacitors in there. Don't put those cheap Chinese capacitors that you can get in there. They may work and they may work for a while, but you don't know if they're going to have the reliability and long life as some of the name brand. And honestly, when you buy them in bulk or you buy a few from Mauser or DigiKey, you can get pretty good deals on them. And so usually I try to buy everything in 100 quantities so I can get a good price. So that's what I'm going to do. So I'm not going to explain the entire process, guys. I'm just going to go ahead and start working on this board, and you guys will see me go and fast forward. Again, making sure that I'm upsizing all my capacitors. Now, we have to make sure that on our electrolytic capacitors, there's a positive and a negative side. And so on this axial electrolytic capacitor, let me zoom in. It has a negative side, which is denoting this way. So when we put this capacitor back in, this is the negative side of the capacitor, this is the positive side. And if we look really closely, and you guys won't be able to see, but you have to take my word for it, on this side there's a little plus symbol on that board, and that just denotes that that's the positive side of the capacitor is going to go there. So making sure that we put these capacitors in with the correct polarity is going to be super important. So you want to make sure you're doing that and you're paying attention. I can't tell you how many times, guys, even a professional, even someone like myself that's done it 100 times, you get busy, you get distracted, and you might get that backwards. And so if you get it backwards, you know, a lot of times nothing happens, but sometimes you can damage something else, short something, and then you wind up with a bigger problem than what you had going into it. As far as the transistors, and I'll put a symbol of a transistor up on the screen above. Now, we've got to make sure that we put these in with the correct pinout. And so as you look at that diagram, we have the E, B, and C. And what those stand for is the emitter, the collector, and the base. And we want to make sure that we put those in the correct order on the circuit board. And so that symbol, a lot of times, will be denoted on the circuit board itself, so you know that you're putting it in correctly. If it's not the symbol, then a lot of times we'll either put E, C, or B to denote which leg of the transistor goes where. So super important. Another thing, when you make your substitutions for transistors, you want to make sure that you're getting something with a similar pinout. Some of them, it doesn't matter. These little transistors, it doesn't matter if the pinout changes much. But you want to make sure that you know the pinout of your transistors. And you can do that by accessing the data sheet from the manufacturer to see what the pinout of these transistors are. These big transistors here, they usually are BCE, I believe. And so one's going to be an NPN and one's going to be a PNP. And so for my NPN, I'm probably going to be using a KSC 2073. And then for my PNP, I'm going to be using probably a KSA 940. and that'll be the transistors I use here. These little transistors, I don't remember off the top of my head which ones I'll use, but I'll just refer to the service manual and make sure I make the appropriate substitution. So without further ado, I'm going to go ahead and get started on that. You guys just sit back for the ride. So to get access to this board, I'm going to have to remove these two screws here, here, and here. And then there's some plastic circuit board holders here that I'll just have to depress, and then that'll give me access. Now this is a tight fit here, so it's going to be fun to do. And I may have to adjust the camera, but let's go ahead and get started. All right, so you guys just saw everything I went to do just to free up this and have as much space as possible. I knew I was going to be working on the amp board, so I just went ahead and remove the heat sink. That's a job within itself. I had to loosen the tray that holds it, had to take out this or loosen this filter capacitor just so I could get access to the screws on either side of the heat sink to pull that off. And I was going to do that anyways because I'm going to apply new thermal paste and new seal pads to those output transistors. If you notice, I took a picture of that before I removed it just to help myself. Another thing to be cautious of when you're messing with that, guys, are these diodes. They act as a feedback loop and monitor the heat on the output transistors. These things are notorious for breaking, and so you want to make sure you're super careful with those because there's not a replacement for these. You can put a couple of diodes in series to do that. But that's obviously not ideal, so I didn't want to do that. Now, one thing I will tell you is that while I was doing that, the dial indicator broke, and so looks like I'll be showing you guys my new thing or trying to fix this one in this video. So that's a little frustrating because I had, you know, if it broke when I was doing this, it definitely would have broke when I tried to replace that light bulb in it. Because if it was that brittle, there's no way it would have withstood the light bulb change in that. So I guess it was a good thing. And it broke clean in one spot. So I mean, if I have to repair this, I can. But I think I have another alternative that I'd like to share with you guys. So I'm going to go ahead, now that I've got enough space on this, I'm going to go ahead and start doing my, I'm going to start with my electrolytic capacitors. And all I'm going to do is pull them out and I'll put a new one in. And so in that way I can guarantee that I'm getting the right one. Again, I'm going to upsize my voltage on these. When I get all these in, I'll go ahead and solder them in, and then we'll start on the transistors, so stick around. And just like that, we've got all the electrolytic capacitors changed. Now you noticed on this one, this was an axial electrolytic capacitor, and I didn't have an axial, so you can use whatever you have as long as the leads will reach. And we've got plenty of room up here, so it doesn't matter that it's sticking up. So like I said, we changed all the electrolytic capacitors. I was lucky I had every single electrolytic capacitor in a plus voltage. So every capacitor was upgraded in voltage on this power supply board, which is what I always try to do. But sometimes I don't have the substitution available and I have to use what originally came in it. But this time I got lucky and I had every single one of these electrolytic capacitors in stock to increase the voltage. Now that's not necessary. It's just a pet peeve of mine that I like to do. And I don't even know if it applies to this receiver or not, but like I said before, some of the manufacturers try to skimp on that and just give you enough voltage to get by. And so for me, when it's the power supply when it's the heart of the receiver, I try to always upgrade all my electrolytic capacitors. So now it's on to the transistors, and so I need to go pull the service manual. And actually, no, I don't need to pull the service manual. I can just look at these transistors here, these small ones, and tell which ones I'm going to need to replace. But we got 4 of them, and so again, we got to make sure we watch the pinout and get the correct pinout in these transistors in order for it to work. And so we'll just go ahead and start on that, and then the power supply board will be done. So let's keep it trucking. So with the transistors, I'm not going to show you guys me doing that. I'm just going to go ahead and replace the transistors. This should be a pretty straightforward installation. So there's only 4 of them, so we'll come back once I've done that. And just like that, we've got the transistors and the electrolytic capacitors changed. And so I was wrong on here. This one doesn't have a PNP transistor on it. So both of these transistors here were actually going to be the KSC 2073s, and the original small little transistors here were the 945. So I actually replaced those with the KSC 945 as well. Now, interesting, watch the pinout on those, transistor if you use that 945, because it actually has a different pinout than a lot of them. It's a EBC versus ECB, and so I had to learn that the hard way on when I was repairing a 939, and I could not figure out why it wasn't coming out of protection after I did some work, and it turned out that I had the wrong pinout of those transistors in there. So we could have used a couple different transistors here. We could also use a KSC 1845. I've seen some people use a KSC 2383 for the power side, but I just went ahead and put the modern equivalents in there, the 945s, since that's what it already had in there. And so be super careful. The other thing, guys, is you saw me doing it in the electrolytic capacitor side, is make sure you trim all your leads. And so you don't want to leave your leads long, because that can create a potential for them to hit this metal down here and ground out and cause a short, and all that hard work you just did, you did for nothing, because you might burn out one of these transistors or one of the power transistors or something else on the board. So you want to make sure that you're doing that. So I do recommend, after every time we work on a board, that you plug it back into your dim bulb tester, and then just check to make sure you don't have any shorts and that you get your relay click. So I'm going to go ahead and get this put back together, and then I'll plug it in, and then I'll check that, and then we'll go ahead and move from there onto the amp board. Okay, so I've got this all put back together. I've got it plugged into my dim bulb tester, and so we're ready to turn this on. Now, if everything goes good, we won't get a bright light, and our relay here will click. And so it'll be hard for you guys to hear, but I'll let you know if it clicks in or not. So I'm going to go ahead and turn it on. No bright bulb. And we got our relay click. So that's a good sign. So it shows us that we don't have a short, and we got the relay click, so everything's working. And so now we're ready to move on to the amp board. So here's the amp board over here. And so this is going to be a little bit easier because I have complete access to this board on the back side of the receiver. So let's take a look at this and see what we have to do. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 transistors on here. And so these transistors with the heat sinks are driver transistors, and those are going to be the PNP, NPN transistors. And so we'll be using the KSC 2073s and the 940s. Now, if you look at these can things right here, these are transistors, and these are known to go bad. And these are KSC, or I'm sorry, not KSC, 1451s. And they're known to go bad, and so what we're going to use to replace those is going to be a KSC 3503. And then these 4 transistors here are 2SA726s, and those are known noisy transistors as well. So we've got 6 problem transistors on this amp board, known to go bad and cause problems and cause some noise in the music. So it's a good thing that we're going to go ahead and rebuild this and get those out of here. I suggest that if you see these transistors on something that you plan on keeping, go ahead and swap them out. Just make sure you're making the appropriate substitution. Now, these 2 here and these 2, they're going to have to be gain matched. And so what I mean by gain match is when we use our transistor tester, we're going to look at the gain that comes on them and get it as close as possible. And so when I go to do that, I'm going to use, I have multiple transistor testers. If you don't have one, I suggest getting one. You can get one of these cheap, very inexpensive ones like this, and it works very well. I've modified mine and I've given it these leads just to make it more functional. And I find, even though this is probably, I paid $10 for this, and even though it's cheap, it is actually very reliable and very accurate. And so I've paid more money for this transistor tester for Nisi, and this thing's a piece of junk. And so I like it for certain things, but for reading transistors and their pinout, I can't trust it because it gets the pinout wrong very frequently. And so I actually went to the company and asked them to fix it. I sent them pictures, sent them examples, and they kind of ghosted me. And they talked to me for a little while and said they were going to work on this, but I haven't heard anything back, and there hasn't been a fix to it. So there hasn't been any updated firmware. So I'm very disappointed because I really like the package size. I really like the screen. It's easy to read. It's very small. So I really had high hopes for this, but this has been a bummer. So if you're thinking about getting one, spend $10 and get this one because it actually works, versus spending $30 and getting this one that does not work or doesn't at least read the pinout correctly on the transistors. So now I have an expensive tester as well, this Peak, and this is always accurate as well. And so if I ever in doubt, I use this one. But I'm honestly, this thing 9 times out of 10 is the first one I grab, just because I can put it in here and it's just a little bit quicker. And if I can't, I'll use the leads. But the leads on here is a lot shorter than the ones I made, and so that's sometimes a pain in the butt. So a lot of times I use this. So I highly recommend this. This is a TC1 tester, and I think I got this off of Amazon or something like that, or Temu or AliExpress. You can find these dirt cheap, and they work really well. So that's what I use for my pinout. And that's what I'm going to use to test the gain on these transistors to ensure that I've matched them correctly. A lot of times you can tell that a transistor's been gain matched because they'll put little dots on top of the transistors. But even though there's no dots on these, from experience I know these need to be gain matched, so we're going to do that. After that, we've got the electrolytic capacitors to change out. We've got 1, 2, 3, 4, just 6 electrolytic capacitors on here. So this is going to go pretty easily. So we should be able to knock this out. I would say that if I was giving an honest estimate, I would say this would be a 30 to 45 minute job here to do this, barring no screw-ups, no complications. And so some things that can happen is if you put your heat on the traces too long, you might damage the trace and then you have to repair it. So barring none of that, this should go pretty smoothly, especially since we got access underneath the board at all. So I'm not going to show you guys that process. Y'all will just have to take my word for it that I'm doing it. But if you have questions about it or any of my substitutions, you can always leave them in the comments down below. So I'm going to go ahead and start swapping out those components. Remember, on the transistors, to pay close attention to our pinouts. And then on our electrolytic capacitors, we want to make sure that we're monitoring our polarity and making sure that we're plugging those in with the correct polarity indicated on the board. Again, if I can, I'll always upsize my capacitors to the next voltage level, but I'm always going to keep the capacitance the same. So not as critical here on the amp board, but if I can do it, I always do it. Just, I don't know, just gives me a little bit, makes me feel good about myself. So I'm going to go ahead and start on that, and we'll come back when I'm done. All right, I figured I'd go ahead and review transistor matching real quick. And so these are my old transistors here that I pulled out of that unit. And so this pair here were very closely gain matched, and so they didn't drift far apart from each other. I think they were off by like maybe 5 points. This pair, however, was off by 20 or 30, I believe. And so drifting, what that means is that over time, basically the gain kind of drifts apart from each other. So if they were matched and they were pretty close to each other, over time they could kind of go their separate ways. So now one thing I will say, and it's kind of hard to see on these resistors, and let me see how good a picture we got here. I'm going to zoom in. Well, I can't get it to really focus, but on these legs, you'll see there's a lot of black on the legs, and that's kind of transistor rot. I don't know if there's a technical term for it or not, but what will happen over time is that rot will go higher and higher on the leg, and then if it gets inside here, it can damage the silicon, and then, you know, the transistor can fail or whatever else. Now, what's weird on this is all four of these transistors, the outer legs have the transistor rot and the middle leg doesn't. Never seen that before, or I've never noticed it before, but I just thought that was really weird that on all of these transistors, the rot is only on the outside legs. Just kind of weird. Figured I'd point it out for no apparent reason. So if you're looking in your stereo and you happen to see the transistor rot on your transistors, especially if they're known noisy transistors like those, it's probably a good idea to go ahead and swap them out. So I've gone ahead and matched these transistors here, and so I'm just going to show you what I'm talking about. And so I'm going to put this into my transistor reader, and hopefully you guys can see that. And so this one is reading a gain of 519, okay? And this one is pretty close. That one is 522. So that's what I mean by matching those transistors, gain matching. And so the abbreviation on here is HFE for gain match. And so that's what we're looking at. And so those transistors right there would be a matched pair. And that's what we're talking about. And so I'm going to match the pair on the left channel and on the right channel. And if I can, I'll try to get all four of them close together. In this case, I think I'm about 10 off, but that's perfectly fine for that. So that was just a quick review over transistor matching. If you have questions about that, Google it. You know, I'm not your encyclopedia. No, I'm just kidding. Leave them in the comments below. There's not much to it other than what I just told you, so I don't think there'll be a lot of questions, but if you do, or if you just want to say hi, you can leave that in the comments. So let me go ahead and let's get these in the amp board. All right, and so now we've got the amp board done. We've replaced all the transistors and the electrolytic capacitors, and so that went pretty smooth, and I'd say it actually took me about an hour, and so a little bit longer than I thought. A couple things I didn't mention before, but these transistors that are on these heat sinks, make sure you put thermal paste behind those transistors. I was reading or watching something the other day, and a guy opened his receiver up, and they had not only made the inappropriate transistor substitution, but they didn't put any thermal paste behind the transistors. And so it's super important, and really that thermal paste does two things. One, obviously it helps with the heat transfer from the transistor itself, but it also, you know, the transistor bottom is not perfectly flat, and the heat sink that it's getting screwed into isn't perfectly flat. So putting that thermal compound on there basically fills in those voids and still allows for that heat transfer, so there's no loss of surface area for the heat transfer to go in there. So don't be too stingy, you know, on your thermal paste. You want to put just the right amount and not anymore. So now that we've done that, I've gone ahead and I've plugged it into my dim bulb tester. We're going to do the exact same thing we did. We're going to power this up, make sure we don't have a short, and make sure we get relay click. Now the output transistors are out, but that's not a big deal. So, because we're going to be applying new thermal paste to those in just a minute. But we want to make sure that we identify any problems before we move on. So and that's why we do this, do the power up board by board, is that way it's just easier to go back and find where we might have done something wrong. And I can tell you that saved my bacon before, because, you know, as you get in a hurry doing this, or you've done it a lot of times, and just your eyes, you know, just you think you did everything right, and you might get the transistors in the wrong pinout. So it's just a great rule of thumb to always power up after each board, just to ensure that it's going to work. So let me go ahead and turn it on. So we didn't get a bright bulb, so that's good. And we just got our relay click. So everything's working and we can move on. So then now that we've got the power supply and the amp board done, I'm going to go ahead and focus on the output transistors. Sorry if you guys can hear that. My lawn man is going by my shop right now as we speak. So I'm going to focus on the output transistors, and we're going to go ahead and remove these output transistors, put new seal pads down and new thermal paste. And so probably not 100% necessary. These TO3 transistors are pretty stocky, and they I don't see a lot of them fail. I mean, for as many of these as I've rebuilt, these are one of the last things that fail. Now that doesn't say that they don't fail, but they're pretty beefy. So, but I'm going to go ahead and remove these, and then we'll put new seal pads on. And so I won't show you guys that process. It's pretty self-explanatory. So what we're going to do is, all we have to do is come this off, pull this off, and then these seal pads will get replaced. We'll wipe off that leftover thermal compound. We'll put a new thermal compound on both sides. So we're going to put it on the here and then on the actual transistor as well, and we'll sandwich the seal pad in between. And then that way we make sure that we get a really good heat transfer between these transistors. And so these output transistors are obviously super important because that's what's really doing the work in our stereo to get that music we love. So I'm going to go ahead and do that off camera, and we'll come back and I'll show you guys the finished product here in a few minutes. Okay, now we have our output transistors with new seal pads and thermal paste applied to both sides of the pad. And so good rule of thumb, just kind of give it a little pressure, push it in. This will allow the transistor and seal pad to stick to the heatsink, because when you go to put this back in, they have a tendency to pop out, and so that'll just help hold it in place when we try to go put back in. So now this is ready to go back in the receiver. We'll do the exact same thing. We'll put this in the receiver, and then we'll do a power up on the dim bulb, make sure everything's good, and then proceed to the next step. So when we come back, I'll have this in the receiver, and we'll go ahead and proceed to the next step, which will be the protection board. So see you in a few. All right, so now we've got everything back together. I've got it hooked up to my dim bulb tester. So we'll go ahead and power it on and make sure we don't have any shorts, and we get relay click. There's our relay click, and our bulb didn't light up, so everything's fine for us to proceed to the next step. So we're moving right along. This is going actually pretty smooth. So next is going to be our protection board, and then from there we'll do the same thing, rebuild that board with new transistors and electrolytic capacitors, and do a power up test. And then from there we'll go ahead and test and see what this thing sounds like. After that, we'll move on to some of the cosmetic things, like changing out these bulbs and getting new lights put in. So let's get moving. All right, welcome back. This is day 2 on this 737, and so today we're going to tackle this protection board. And so this should be pretty straightforward. This is not the exact same board as what the 838 and 939 has in it, but it's actually a different board number, but as far as I can tell, they're exactly the same. Use the same transistors, everything. The circuit looks completely the same, so I'm going to use that to do this. Pretty straightforward. We've only got what, 1, 2, 3, 4, 5, 6 capacitors and 7 transistors, and so I'll be using electrolytics for these, and then I have some film capacitors that I'll be using here, and then I'll replace all these transistors as well. One thing on this is that I'll be installing a flyback diode from pins 9 to 10 with the cathode either on pin 10 or 11. So 10 or 11 are joined together on the circuit board, so it doesn't really matter. But since there's 2 wires on 11, I'm going to be putting it on a 10, and I'll use my wire wrap tool. If you're doing a lot of this repair work, this is a invaluable tool. I use this a lot. I'm really glad I got it. It helps me frequently, and that's just a wire wrap and unwrap tool. So first thing we have to do is get access to this board, and so you'll see these plastic grommets on the 4 corners. We just have to depress those and then move this circuit board out of the way. From there, that'll allow me to lay over the circuit board and start unsoldering some of these components. So this is going to be the same process as what we used on the power supply board and amp board, so I'm not going to show that. I'm just going to go ahead and do it, and we'll come back and test it when we're done. So I'll be back in a few. So I haven't really talked about soldering much, and so I figured I'd stop the video here and talk about it a little bit. The key to soldering is having good solder. So if you're soldering and it's clumping up and it doesn't seem to want to stick to the pads, and you're having an issue, you're probably using the wrong solder, and you should probably stop because you might damage your components. Because if we keep the soldering iron too long on one of these pads, you can risk the pad coming up and damaging the pad, and then you have to repair it. And it's not the end of the world. You can repair it, anything you can repair, but it just adds, you know, that much more work you have to do. So when I solder, and we'll show here, like it just takes that long, you know, so that's it. And the solder just kind of goes where it needs to go. And what I do is I'll heat up the pad, and then I'll transfer the tip of my soldering iron to the leg of what I'm heating up. You know, on these little small transistors, not so much. On the bigger transistors, I can do that, but it should be very, very easy. The solder should want to flow right to where the heat is. So if you're having a hard time, like I said, you need to stop and get the right solder. If it's clumping up on you, that's a dead giveaway that you're using not electrical solder. You're using the wrong stuff, and you should stop, because you don't want to damage this and cause more work for yourself. So I don't use expensive solder, and I get it off of Amazon, honestly, and it's a combination of tin and lead, 40-60, 60% tin, I think 40% lead. There it is right there. Hopefully it's focused on the camera and you can see that. You know, this isn't very expensive solder, but it works very, very well. It's got flux in it. And so that's what I use. And if I remember, I'll put a link in the description so you guys can buy this solder. I think I want to say I pay maybe $10 for it. And it lasts a long time. And I've been really impressed with it. And I've been using it since I started doing this. I just keep buying the same stuff over again, because if it ain't broke, why fix it? So just want to take a second and talk about solder. And if you guys have any questions about soldering or anything else like that, you guys can leave them down in the comments below. Okay, so now we're going to install the flyback diode, and this is my wire wrap tool that I was telling you guys about, and I really like this thing. I think I got this on Amazon. I can't even remember, but I use it all the time, and so it's going to make this job really easy. So we're going to put the cathode on pin 10 and the positive side on pin 9, and all we have to do, and it's probably hard to see this, let me zoom out just a hair. Well, there's a little hole, and we'll just slide it in, and then we'll put the top on pin 9, and then all you do is twist. And you want to apply a little downward pressure so it gets nice tight wrap. And now we're going to do the same thing to pin 10. This is where it kind of gets a pain in the butt because they're close together, but no big deal. We can handle it. And we twist again. And just like that, we have our flyback diode installed. And this just gives some added safety to the circuit when it de-energizes. And so we don't want any stray voltage or current that can cause some damage. So that's what that flyback diode does again. And so just to recap, I put the cathode side on pin 10, and the other one is on pin 9. And this, like I said, this just protects the circuit during de-energization. And so, as you can see, we've completed the protection board. So we've got all new transistors and caps in there. We've got our film caps here. Now, you don't have to put film caps here. You could use electrolytics. They had electrolytics in the circuit. I've just done a bunch of these, and so I got these film caps from Mauser, and they were pretty cheap, so I just use them because that's what I have. But you could totally use an electrolytic capacitor here, so don't feel like you have to use film. I've done it both ways, and either way, it works fine. It sounds good. One thing I didn't mention is that these two transistors here, I would go ahead and match. And so gain match, like we talked about on the amp board. So these two transistors are gain matched. And so, but that's it. So that's the protection board. Now we can move on to basically making sure that cosmetically this thing looks good. And so we're going to go ahead and change the LEDs on the very front and start working on the indicator lights. All right, so now we're going to go ahead and start on replacing some of these fuse lamps in here. In order to get access to this, there's a couple things we have to do. We're going to have to remove this, and to do that, there's a little black bracket here that's holding the top in, and so that we got a screw here and a screw here. So we'll remove those, and then we'll gently start to peel this back. Now there's a glue strip at the bottom, so you want to be very careful because over time this can get a little sensitive and we don't want to crack it. And I've done that before and it sucks, so we want to be very, very careful with that. Now, I don't know if y'all remember on the other part of the video when I was doing the power supply and just leaned up against this dial indicator broke. So that's one less thing we're going to have to worry about. So we're going to have to fix that though when we get to the lamp part of that. But we'll remove that from this little black bracket, and then we'll go ahead and get these screws out. Once we do that, this will just come right out, and we can set that off to the side. And then now that frees us up to go ahead and start to do that. Now what I recommend is getting like a little plastic putty knife or something and using that to kind of help pry at the bottom. Because like I said, you don't want to apply too much force and risk it snapping. So you kind of just want to work it back and forth. Just being super careful and just waiting for that glue to release. And it doesn't take a lot of force, and it'll slowly start to come up. But you don't want to bend too much, and what you can do is slide this in between. And this is where you want to pay really close attention right here, because the plastic gets a little thinner here where the meters are, and it makes it a lot easier to snap. Ask me how I know, but we're just going to use our knife and just put just a little bit of pressure there. And it comes right off. And so now we're going to set this off to the side in a safe place. We'll do a cleaning on that before we reuse it. And now that gives us access to all these LED or these fuse lamps in here. And then we have a screw here that we'll have to take off to get access to the fuse lamps behind these meters. So I'm going to go ahead and change the camera view so you guys can see this, and I'll show you guys how simple it is to replace those. All right. So as you guys can see, we have the fuse lamps in here, and there's 5 here and there's 2 in the meter. So we'll need a total of 7 fuse lamps. And all I'm going to do, guys, is this kind of little flat tip screwdriver, and I just pop them out, and then they roll out to me, and I just catch them. Very simple. Now once I have them out, then I've got to put the LEDs back in, and what I use is a needle nose pliers, and I'll just hold it just on the tip and just put it up and just snap it in. That way I know the LEDs are facing me and I don't have to mess with it. And then they go in nice and easy. And I'm putting some blue or ice blue LEDs in here. I like the way these look. They look really sharp and close to the original, but give a more vibrant color, I think, so it looks really good. And we're done with that one. So now we'll do a quick test run, make sure they're all working. All of them are working. So we're ready to move on to the meters. So I'll go ahead and change the camera view and we'll move on to the meters. Here's the meters behind this, and what we have to do is remove this screw, and it's kind of buried behind these wires here. Just one screw. I think on the 838, 939s it's 2 screws, but on this one it's just 1 screw. Once we do that, it's going to be hard to film, but we'll just basically move the shroud back. Actually, we got a pretty good amount of flexibility here. And the fuse lamps are right behind here, and so I can't get you guys a really good camera view, but I'm going to basically just pop them out by hand. Hopefully. Maybe not. Maybe I'll use a screwdriver. And you can see those are burned out. And then go ahead and place the LEDs. Now, you want to make sure you point the LEDs towards the meter when you do this. You don't want to take them out because you're wondering why they're not working. So what I like to do with this is pop one side in, and then that gives me the leverage just to use my finger and pop the other side in. And so that's all there is to it. We'll go ahead and replace our screw. And now we're ready to move on to the indicator lights. So the indicator lights, to do this, we're going to change the camera position a little bit. We're going to have to remove this metal shroud here, and that'll give us access to these light bulbs behind here. Now, we've got one for the stereo and 1, 2, 3, 4, 5 indicator lights. And this is usually the part of the job that I absolutely hate because it's just small, it's tedious, and just a pain in the butt. So I don't like doing this. But let's go ahead and remove this plate. We're going to do that by removing this screw. There's a screw right here, and then there's a screw over here on this plate here. So we'll go ahead and do that. Set those screws off to the side. And now this plate will come out of the way. And we can just pop this wire out. And we can remove this and put it off to the side as well. And so now you'll see that we have access to all these wires. And we can go ahead and start on that. Now I'm going to use LEDs for this as well for a couple of reasons. One, the heat that we always talk about. And so for this LED, I'm going to use a red LED because that's the color of the stereo. And I know the screen is red, but I like putting a red LED here just to kind of give it a little bit. And then on these ones, I'm going to use white LEDs on these remaining 5 LEDs. So I'm going to go ahead and get that set up, and then we'll go from there. Okay, so I've got all my supplies ready. I got my LEDs, and so I'm going to do this a little bit differently than what I usually do. Usually what I do is I'll cut these wires and splice directly into these wires. But on this particular one, these wires are going to the back side of this board. And so we have 2 sets here. We have our signal wires, which is where our positive, our 7.5, 8 volts are coming in at. So we got 5 indicators, we got 5 positive. 1, 2, 3, 4, 5. And then we got our ground wires, where basically ground is. And these posts here and this post where we ground. Now where we ground it at doesn't really matter. And so we could actually just put all the grounds to one post. We could spread it out. It doesn't matter as long as it's grounded, because what happens is that when the power goes here and it gets grounded out, that's when the LED will come on. And so what I'm going to do is follow these wires back to where they go, and then that way I can connect to make sure I connect to the positive, and then I'll just solder right on. I'll cut the wires kind of short, and I'll just solder right on to the top, and then we'll test it out and see if that theory works. Make sure that my polarity is correct. And so we'll go ahead and do the stereo light last, and we'll just go in order right down the line here. And so I suggest doing these one at a time. That way you can test it one at a time and make sure that you got it correct before proceeding to the next one. So one at a time. So these bulbs over time, guys, they heat up this plastic, and this plastic becomes very, very brittle. So it's really hard to get these bulbs out a lot of times. Sometimes you can get them out this way by pulling them out, but oftentimes what I do is I cut off the wires and just push them from the front. I'm not going to change the camera view, but you guys saw it previously. Those bulbs just sit right there. So if you cut these wires and push from the back, the bulb should pop right out. So I'm going to do that on this very first one. Set these wires off to the side, and then I'm just going to kind of push it forward. And like I said, it comes right out. And if I would have tried to pull this way, I probably would have busted this whole backside out before this thing would have come through. So it's a lot easier to cut the wires and use those wires to push forward than it is to try to pull this bulb out from the back. And so now that I've done that, it's very easy for me to go in here and solder another light in. So you can see I've got my LED here. So I've got my red and my black wire. So guess what? My red is going to go to this where this white is, And then my black is really going to go to any ground that I want it to go to. So I've got my choice. This whole side here is the grounding here of these fuses. So I can solder there, I can bring the wire over here, doesn't really matter. So all I'm going to do is kind of make test fit. You know, another good thing you could do, guys, if you're having a hard time, is slide the wires through the hole and pull it through that way. And then that way you're not trying to bust through the front of it. And so that's perfect. That's exactly how I want it. So before I cut these short, I'm going to go ahead and just test what I was doing, what I was talking about, and see if I get a good connection, and we'll plug it in and test it. Make sure I was right on my polarity here. So I've got that going to what I think is ground, and I did test it with my meter, but for some unknown reason sometimes I get these things wrong. May need a little solder on that one. Okay, so I've got that hooked up, so I'm just going to do a quick power test. I got it on my dim bulb, and it works. So that means I'm right, and that's going to save us a whole bunch of time as far as splicing these wires, and save us a whole bunch of time. So I'm going to turn it off. Now what I'm going to do, guys, is I'm going to shorten these wires to make it a little bit neater. I'll go ahead and do that, and I'll repeat that process for every single one of these indicator lights, including the stereo light. And then when I get done, I'll come back and show you guys what it looks like. All right, so I've got all the indicator lights swapped out. And so I tested everything. Everything's working. So this turned out really well. And so much easier going and soldering to these terminals. And I did it as neatly as I could. And so this is going to be all covered by that shroud. And I'll put that back on here in a second. And so that's really going to improve the life of these. This won't have to be done for a very long time with these LEDs. And it won't generate the heat, so that's a win in my book. So I'm going to go ahead and put that shroud back on, and then we're going to move to this indicator light. Now this indicator light is going to be probably the biggest pain in the butt because we don't know what kind of shape this black little box is in, and so we'll have to be very careful since we already know that the indicator itself snapped. We'll have to figure out how we're going to fix that. So, and I might have a theory on how to do that. So let me go ahead and get that shroud back on. We'll change the camera view. I got to go get a part, and then we'll come back and we'll tackle this indicator light. And after that, we'll be done with the lighting. All right, guys, welcome back. So I got everything I think I need. So as I was talking about before, this is very common with these X3X series, is that this indicator will break. That bulb just cooks these, and they just get so fragile that any slight movement the wrong way will break them. And so there is no replacements on the market available for this. So you're either have to do one of two things. One, you have to glue this back on, or try to find a dial indicator from a donor unit. And so with that in mind, I set out to design a new replacement for these. And so as far as I know, this is going to be one of a kind. And what I've done is I've created a CAD file, and I've been able to 3D print this light box and also 3D print the dial indicator. And I must have printed probably 50 of these, and varying the material I was using, varying the depth, the layers, the transparency, all kinds of different settings to try to get one that transmitted the light as good as what it needed to be in order to do this. And so after a lot of trial and error, I'm happy to announce that I think I'm going to be the first one that actually sells these, and I'll be selling these for the I guess for all the X3X series. And so they do come in different lengths. You know, the 838s, 939s, and the 1010s are a little bit longer than the 737s and the 636s, but I'll be able to manufacture and produce these as direct drop-in replacements. And so I'm super excited about that, because I can't tell you how many times I've worked on these and this has broken and given me a lot of issues, because you know, you're really just left at the mercy of, can you fix it or can you find another one from another unit. And so this is going to allow me to just manufacture my own and replace them. And so these will be, they're super flexible too, so that's a cool thing. You know, they're new, so they're super flexible. The light box is brand new, and so this is all 3D printed. I do recommend only using these with LEDs, because incandescent lights do get really hot. They could potentially melt the plastic. So I would only use these if you're using an LED. But like I said, as first as I know, this is going to be the first to market, and this will be the first machine that I've put it in. So we'll take a look at this light box and see how good a shape it is and go from there. But I made my light box a little bit deeper, because I noticed with the original light boxes that they're pretty narrow, and then if you try to put an LED in there, a lot of times it doesn't fit. So I'm going to go ahead and start taking this apart. And to do that, I'm going to have to peel back these flaps. Now this is going to be really hard for you guys to see, so I'll throw a picture up on the screen here in the corner so you guys can see what I'm talking about as far as these metal flaps. And what I'm going to have to do is these little metal flaps, and I'll just have to kind of peel them off on the left and right side and the front and back. So there's 4 of them. And so this is usually, if you're going to break something, this is about the time you do it. So I'm going to do my best to do this and ensure that I don't break anything. Easier said than done. The pressure's off though now that the indicator's already been broken. So, and sometimes a very small flat tip screwdriver helps with this process. If I can find mine somewhere. That's not what I wanted. Where is it? That didn't work. There we go. And this is pretty flexible metal. So usually when you get one side out, you can kind of shimmy the other side out. And so there we have it. Now this is, the light box is out, and you can see the leftover remnant of that indicator in there. So I'm just going to pop that out. Oh yeah, it's cooked in there. And it broke into a bunch of pieces. So just to show that mine, if you didn't need the light box, mine is a direct replacement. You can just go right in here with it, and there's my new dial indicator in the original manufacturer's light box. And so I probably won't use this light box for all the reasons I just talked about before, as far as this being pretty narrow. I'm going to use my engineered light box that I made and manufactured just for this reason, because it gives me a little bit more space, and then I'll just put it back in there and then fold those flaps over it as well. So, but before we can do that, we've got to go ahead and get an LED in here, light, and this process is going to be exactly the same as far as what we did with the indicator lights. I'm probably going to cut this wire and then splice into it, and then I've got to find I've either got to put a resistor at the beginning of the positive side or right before the bulb. I'll probably do it at the beginning, so over here of the circuit. Let me show you guys what I'm talking about. So those wires come over here and attach to this post and this post. So one of these are going to be my positive and one of these is going to be my negative. So I'll turn that on here in a second, and I'll test from one of these leads to ground and see where my voltage is, and then that's where my resistor needs to go. Will be on the positive leg of that wire. So then that way it doesn't short the LED when I go in there. So I'm going to go ahead and get started on that. I'm going to do that off camera, guys, because it's really hard to work with the camera in the way. And then I'll show you guys what I did when we get back and how it works. All right, guys. So here we have the final product. All the lights have been done. That indicator light worked out great. So that's the new light box that I made and the new dial pointer. And I have a and it's super bright, and so brighter than the original, and so everything's working really good on it. My stereo light works, everything's working. So very happy with how this turned out. So I think we're going to call this a win. So I'm going to be selling these on my website. I still have to design a few more and work out some bugs, I think, as far as exact layout for the distance I think I've got the 838, the 939, and the 1010 distance, and then now this 737. And so I've been kind of lazy. I've actually had this design for quite a while now, and I just haven't put it on the website. But I know there's a lot of people that could probably benefit from this. That's dial indicator is broken or light box is broken, and so this is a great alternative, I think, and just as good as the original. Super bright. You know, it's hard to tell on the camera, guys, how good this looks in person, but you'll just have to take my word for it that this looks really, really sharp. And I think the new owner is going to be very happy with the lights. The other benefit with the lights is that since everything's LED, we don't have to worry about the heat, and they're going to last for a very, very long time, hopefully, and no one's going to have to come back in here and change out these lights. So this unit is pretty much done, guys. The only thing left to do to this is clean the potentiometers and switches. And so I've done a video on that before, so I'm not going to go into detail about that now. But I use Deoxit on the Deoxit D5 on the switches and the Fader Lube on the potentiometers. And all I'm going to do is give a good spraying in there and then work the switches back and forth. So I'm not going to show that process because it's really tedious and there's not a lot to gain from there. If you have questions about that, leave them down in the comments below. But this unit is pretty much done. I have to just clean up the faceplate now and clean off the case and put it back together, and this is ready to ship out. So electrically, this thing sounds really good. Once I get it all back together, I'll go ahead and show you guys the finished product, and then we'll go from there. So I'll be back when I've got that done. All right, so we've got this thing finished up, and as you can tell, it's looking really good. And so let's just review what we've done to this. So I went ahead and put a new vinyl wrap on the case. I've cleaned off the faceplate and all the knobs. I've redone the lighting. All lighting inside this now is LED. I used my new dial indicator that I made and my new light box on this model. So this is the first one that's been used on, and so I'll have those available at some point for sale on my website. And my plan is to have those available for the, I don't know, at least the 737s, 838s, 939 and the 1010, and I'll probably wind up doing the 636 and the 535s and 435s at some point as well, but each one's a little bit different, and so I need to take those apart and measure them to make sure that they'll work. And electrically, internally, what we've done is we've rebuilt the power supply board with new electrolytic capacitors and transistors. We've also done the protection board with new transistors and electrolytic capacitors, and we've done the amp board with new electrolytic capacitors and transistors. And then we took out the output transistors and put new thermal paste and seal pads on those as well. And so we cleaned all the controls, and this thing sounds really good. I've listened to it for a few hours, listened to a record on it. Everything's working. So it's ready to be going to its new home and new owner. So, but it looks really great, it looks really sharp, but you guys don't have to take my word for it. I'm going to go ahead and show you some pictures. So pictures are worth 1,000 words, right? So this thing looks good. And so I hope you guys enjoyed this video. Maybe some of you newbies out there learned something. If you have any questions, make sure to leave them in the comments below. I'm really good about trying to answer questions. And then if you haven't already, go ahead and subscribe to the channel. We are growing and we can use all the support we can get. And so as always, thanks for watching, and we'll see you on the next video.